Draw the structure of butanone. So ONE means a ketone, and the functional group of ketone is CO, and but is 4 carbon. So this is a 4 carbon ketone. So first we write the 4 carbons. 1, 2, 3, 4. Now we put the functional group. Functional group is ketone. So I'm putting the functional group in any one of the carbon you can put in the middle carbon, never at the sides. For ketone, the functional group is always in the middle. So you cannot put it on this, nor can you put it on this. You need to put it either on this carbon or on this carbon. And now the 4 arms of the carbon. So you have hydrogen, hydrogen, hydrogen. This carbon has already 4 arms, the middle second carbon, so you don't need to add there. Now here 4 arms. Make sure each carbon has got 4 arms. This is butanone. Next is hexanal. Now it is Al is aldehyde, and the functional group of aldehyde is CHO. Now hexane means 6 carbon. So this is a 6 carbon aldehyde. So first I write the functional group. And now I need to have 6 carbons. 1 is already there. This is already 1. 2, 3, 4, 5, 6. Now the 4 arms of the carbon, here 1 arm is already here, 1, 2, 3, 4. So hydrogen, hydrogen, hydrogen. The next again 2 arms are already there, so 3, 4, hydrogen, hydrogen. Then here for the next one, 2 arms, 3, 4, 2 arms, 3, 4. Each hydrogen should have, each carbon should have 4 arms. 2, 3, 4. So this is your hexanal. Now for propanoic acid. Propanoic acid. Now it is oic. Oic means it is an acid. And acid functional group is COOH. Now propane is 3 carbon. So this is a 3 carbon acid. So first we write the functional group. Functional group is, this you must know, OH. Now I need to add 3 carbons. 1 carbon is already there. So I have here. Now each carbon has to be given 4 arms. So 1, 2, 3, and the 4th is here. So we have hydrogen, hydrogen, hydrogen. 1, 2, 3, 4. Hydrogen, hydrogen. So this is your propanoic acid, 3 carbon acid. Next is pentanol. Pentanol, all. So OL, alcohol. Alcohol functional group OH. Penta means 5 carbon. So first we write OH. Now I've got to attach 5 carbons. 1, 2, 3, 4, 5. Now each carbon has to be given 4 arms. 1, 2, 3, 4. So we have hydrogen, hydrogen, hydrogen. So 1, 2, 3, 4. 1, 2, 3, 4. Again 1, 2, 3, 4. And 1, 2, 3, 4. That's pentanol. Now butene. ENE means it is an alkane. Alkane means it is a double bond. And but is 4 carbon. So this is a 4 carbon alkane. So 1, 2, 3, 4 carbon. it has to have a double bond. Now the double bond could be anywhere. It could be in the first place, or it could be in the second place, or it could be in the third place. However, these are different compounds, but for now, as I told you earlier, we will keep it in the first place. So we have put the functional group, we have put the 4 carbons. Now we have to give 4 arms to each carbon. So first carbon, 1, 2, 3, 4. Then again 1, 2, 3, 4. Now look at this carbon, 1, 2, 3, 4. Only one hydrogen can attach. This carbon, 1, 2, 3, 4. So this is butene, the structure of butene. Now for benzene, benzene is a little different compound, and you need to remember this benzene. It is a 6 carbon alkane. So for writing benzene, first you need to write 6 carbons in a circle. This you need to write. Then you need to put double bond between the carbons. Now it's time to put the hydrogens. Look at each carbon. This carbon, here I made a mistake. It's not double bond throughout. At alternate places there is double bond. Let me do it again. So I need to put first 6 carbons. 1, 2, 3, 4, 5, 6. And you just attach them with the bonds. Now every alternate you got to put a double bond. Like here, you leave this here, here. Right? I think I'll put the bonds in green. 1. This is the main structure. Now we put the hydrogens. You see for the one carbon, 1, 2, 3, 4. Then you have for the next carbon, for this carbon, 1, 2, 3 and 4. For the next carbon, you have again for this carbon, 1, 2, 3 and 4. For next carbon, 1, 2, 3 and 4. Here carbon 1, 2, 3 and 4. So this is benzene. This carbon also has 4. 1, 2, 3 and 4. So this is the structure of benzene. Next is cyclohexane. So first hexane means 6 carbon. So I have 1, 2, 3, 4, 5, 6. Just like benzene. Then you attach them with a single bond. Like unlike benzene, this has got only single bonds. So if I take this carbon, there are 2 single bonds and 2 more can be attached to make it 4. So I have next carbon, 1, 2, 3, 4. Then this carbon, you have 1 here, 2 here, 3, 4. Next carbon again, this carbon, 1, 2, 3, 4. So hydrogen, hydrogen. Now here carbon, 1, 2, 3, 4. Hydrogen, hydrogen. Now last carbon, carbon, 1, 2, 3 and 4. So this is your cyclohexane. Every time you write a structure, make sure every carbon has got 4 arms. Here let's check out for this carbon, 1, 2, 3, 4 arms. See next carbon, 1, 2, 3, 4 arms. In this manner you got to check all your carbons. Name the third member of alcohol. Now alcohol is OH, functional group, and because it is third member, it should have 3 carbons. So I'll put now 1, 2, 3 carbons. So it will be H3, H2, H2OH. So third member of alcohol will be H3, 1 carbon, H2, H2OH. and 3 carbon. So because it has got 3 carbon, it is propane. Propanol alcohol. Propanol will be the 3 carbon alcohol. Now for its structure, you write 1, 2, 3 OH, and now give the hydrogens. 1, 2, 3. You'll have hydrogen, hydrogen, hydrogen. The second can accommodate only 2 hydrogens because the 2 bonds are already attached here. The third also can accommodate only 2 hydrogens because 2 are already attached here. That is why you have the first is CH3 while the others are CH2, CH2. So the third carbon alcohol is propanol. All because it is alcohol. Propane, 3 carbon. 3 carbon means third member. Now we need to do second member ketone. Now for ketone we know the functional group is CO. Now ketone, you'll probably think because it is second member it has to be 2 carbons, and that is wrong. Because if you remember, ketone, the first member of ketone is propanone, is this CH3. Ketone starts with 3 carbons. The first member starts with 3 carbons. That means the second member will have 4 carbons, and the second member will be CH3, CO, CH2, CH3. This will be the second member. Now if you see, the second member has got 4 carbons, so it will be Butanone. The one means it is ketone. I'll write this in another one. So it is butanone. Second member of ketone is butanone. And just to revise, the first member of ketone is not 1 carbon. The first member starts with 3 carbon. Ketone starts with 3 carbon. So it will be CH3, CO, CH3, and that is propanone. First member of an acid. The functional group of an acid is COOH, and the first member in this first member will have 1 carbon. This goes in order. So here we have now COOH, and the carbon is already there. It can have only 1 carbon, so I put HCOH. The structure of this will be H, C double bond O. Oxygen always has a double bond, and this is OH. This is 1 carbon acid, and because it is 1 carbon, it is methane. So methanoic acid. Oic because it is an acid. So methanoic acid is first member of acid. The acid group starts with first member. First member 1 carbon. Second member 2 carbon, and so on. This is for the acid. Now just to revise the ketone, what we did in the last slide. If you remember the ketone, the first member was not 1 carbon. The first member was 3 carbon. So second member became 4 carbon because ketonic group was in the middle like this. There are attachments on both the sides. There's carbon here, carbon here. So this is the first member. It starts from 3 carbon. Now third member of alkane. This is also an unusual series. So alkane means double bond. Third member, so you expect it to be 3 carbon. But no, it is not 3 carbon. Because remember alkene, this is the first alkane. CH2 double bond CH2 is the first member. And the first member has 2 carbons. The second member will be CH2 double bond CH2, now CH here. If you do the structure, you'll find it has to be CH, CH3. The second member of alkyne. Now alkyne is triple bond. So second member, you'd probably expect it to be 2 carbon, and it is not, because when it comes to alkyne, the first member has 2 carbons. The first member is just to have triple bond. So this is the first member, and since it's got 2 carbons, it is called ethyne. It is a 2 carbon with a triple bond. Now the second member has 3 carbons, and it will be 1, 2, 3 triple bond. And if you see, this will be hydrogen here and 3 hydrogens, and since it is a 3 carbon, it is propane. 3 carbon with a triple bond, and that is the second member. So let's write the structure of second member. What is in the question is second member. So you have 1, 2, 3, and we have to give triple bond. Let us start here. 1, 2, 3, 4. So hydrogen, hydrogen, hydrogen. Here you have 1, 2, 3, 4. So this carbon has no place for more hydrogen. The last carbon, 1, 2, 3, and then you have 4. So this is now, the name of this is propane. Second member is propane. Although it is second member, it has got 3 carbons. Because alkyne, the first member starts only with 2 carbons. There is no 1 carbon of alkyne. Name the functional group in the following. So if pentanol, al is aldehyde, it is CHO aldehyde group. Then for next, bromopropane, bromo, Br, the halogen group, is the functional group. Then we have butane. Butane is an alkane, and they're just single bonds. You can say the single bond is the functional group. They're all single bonds. Propanol, all is alcohol. Alcohol is OH, so functional group alcohol. Propanone, one is ketone, functional group CO. Then we have hexane. Ine is triple bond, so it's an alkyne. Functional group triple bond. Then here we have methanoic acid. Oic is COOH. It is a carboxylic acid. Which of the hydrocarbons belong to the same series, and name the series? Now we know we have 3 series. One is the alkane, and the general formula is CnH2n plus 2. Then we have the alkene, general formula CnH2n. And then you have the alkyne with the triple bonds, general formula CnH2n minus 2. Let's take up the first one. The first one is C2H10. And if you see C2H10, this can be C2H10, it is C5H10. Now C5H10 is, here you have C5, and H is 2 into 5. So you definitely agree it belongs to this group, C5. C5H10 will belong to this. 2 into 5 is 10. Now we go to the next. Here we do C3H4. C3H 2 into 3 is 6 minus 2. So the general formula for this is C3H6 minus 2, right? And that would belong to alkyne. So C3H4 will have a general formula CnH2n minus 2. Next is C3H8. This is C3H 2 into 3 plus 2. That would be C3H6 plus 2. And that would belong to alkane. So this is an alkane, C3H8. Then next is C2H6. C2H6. That is C2H2 into 2, 2n. We have to get 6, so plus 2. So this is C2H4 plus 2. So plus 2 would be here. So C2H6 would be a alkane. Once again, so alkane is 2n plus 2, general formula. Then we have alkene with double bond CnH2n, and then alkyne CH2n minus 2. We'll take up the next one, and this is C6H10. Now C6H10 will be C6H10 is 2 into 6, 12 minus 2 to give you 10. So C6H12 minus 2, and that would belong to alkyne. So C6H10 would belong to alkyne. Next we have C2H4, which is C2H2 into 2. That's it, we got 4. C2H4. So that would be an alkene. C2H4. Then we have C4H10. C4H2 into 4. That is 8. You have to get 10, so plus 2. So C4H8 plus 2, alkane. C4H10 would be an alkane. Then the last, C7H12. That is C7H2 into 7, that is 14, but we need 12, so minus 2. So C7H14 minus 2, and that would be 12. That is, minus is alkyne. So C7H12 would come as an alkyne. Give the general formula of an alkane, and we've done it just now. An alkane is CnH2n plus 2. Then alkene. Alkene general formula CnH2n. And last is alkyne, CnH2n minus 2. Write the molecular formula of an alkane with 20 carbons. So we have alkane, the general formula CnH2n plus 2. Now they want 20 carbons, means N equal to 20. So equal to C20H2 into 20 plus 2. C20H40 plus 2. So C20H42 will be an alkane with 20 carbons. Next we have to find an alkene with 20 carbons. So we have alkene, formula CnH2n. So here N is 20, to C20H2 into 20. C20H40 will be an alkene with 20 carbons. Now we need to find an alkyne with 20 carbons. So third one is alkyne. alkyne general formula CnH2n minus 2. So alkyne N equal to 20. So C20H2 into 20, N is 20 minus 2. That is C20H40 minus 2. C20H38 would be an alkyne with 20 carbons. Which of the following has double bond? Now we know C4H10. To which group does it belong? So we do C4H2 into 4, that is 8, plus 2 it is, right? So this will belong to CnH2n plus 2. It's an alkane. CnH2n plus 2 is an alkane, and this have only single bonds. Next we have C5H8, and this is C5H2 into 5, that is 10. We need 8, so minus 2. So this has a formula CnH2n minus 2. Minus 2 is alkynes, and alkynes have triple bond. Then for the last we have C5H10, which is C5H2 into 5, so that would be 10. So this is CnH2n. These are alkanes, and they have the double bond. So which of the following has double bonds? This is the alkane. So this will have double bond. Give the isomers of butane. So first let's write butane. Remember, butane is 4 carbon. So we need to write 4 carbons first. 1, 2, 3, 4. Now we can arrange this in another manner. We can do it like 1, 2, 3 and have one branch here. Right? Now we need to put our hydrogens. 4. This is hydrogen, hydrogen, hydrogen here. 2, 3, 4. Here's hydrogen. This also 4 hydrogen. It's a straight line, and such a compound is called N-butane. Now for the second one, again we are going to put hydrogens. Hydrogen, 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 and remember there was a carbon attached here. So this carbon also will have one hydrogen here, one hydrogen here, one hydrogen here, and this is the third. So here also 1, 2, 3, 4. 1, 2, 3, 4. So this would be also another structure of butane. We'll just write it again to become a little neater. So CH3, then we have CH, then here we had CH3 and CH3. Now if you notice, the attachment is on the second carbon, and such a compound where attachment is on the second carbon is called iso. This is isobutane. So these isomers are basically compounds having the same molecular formula but different structures. And if you notice now, butane has got 2 isomers. This is one N-butane, and second is isobutane. Those 4 carbons could be arranged in 2 different ways. Now we'll go to pentane. Now pentane has got 5 carbons, so you'll have more isomers. One will be the straight chain, 3, 4, 5. I will write the hydrogen a little later. Okay, and I won't write the hydrogen. You need to write it in the exam because it Just makes a little bit of confusion here, not so clear, so I'm not writing the hydrogen. So this is called the N-pentane. We could arrange the same structure in a different way. 1, 2, 3, 4 I could have done and put it here. Now have you seen, this is first, second, the attachment is on the second carbon. So such a thing is called isobutane. However, I repeat, you need to put your hydrogens everywhere. Isobutane. Or you could have another arrangement. You could have 1, 2, 3 with both the carbons attached to the same. And this is called Neuropentane. When there are 2 attachments to the second, this is the second carbon. When there are 2 attachments to the second carbon, it is called Neuropentane. However, you need again to put your hydrogens. Here 2 hydrogens. So pentane has got 3 isomers. N-pentane, isobutane and neuropentane. How many isomers of the following hydrocarbons are possible? So let me take up C3H8, which is propane. 3 carbon propane. So one would be 1, 2, 3, which is N-propane. And if you see, no more are possible. Even if I do this, it is the same thing. It is a long chain, see, attached in this manner. There are no branches. So for propane, there are only 3. Of course, you can have a cyclic, which we will not learn now. We just go to straight chain compounds. So this is N-propane. Next, we go to butane. 4 carbons. So you have 1, 2, 3, 4. That is N-butane. We have done butane. Then we could have 1, 2, 3 with an attachment here. So this would be now isobutane. Don't forget to put your hydrogens. Each carbon should have 4 arms. Here also, each carbon 4 arms. So butane has got just 2 isomers. You could also put cyclic. Here I'm leaving cyclic out. We are doing only straight chains. Now this is pentane. 1, 2, 3, 4, 5. N-pentane. Then we could do 1, 2, 3, 4, 5. This is isobutane, because the attachment is on the second carbon. That's isobutane. And then we have the neuropentane, where you have 1, 2, 3, 4, 5. So this is neuropentane. C6H14. This is hexane, and it will have a couple of them. 1, 2, 3, 4, 5, 6. And usually till they ask till butane, and they don't ask pentane as much. Sometimes pentane. Hexane is definitely not asked. I'll just tell you, in hexane, it could be 1, 2, 3, 4, 5, 6. This would be isohexane. Or it could be 1, 2, 3, 4, 5, 6. This would be neohexane. You could have many more also, like you have 1, 2, 3, 4, 5. I could attach it at this place, at the 5th place. So we could have here and here also 1, 2, 3. This too. Of course, it's also neohexane. So there could be different arrangements where you can attach the carbon at different places. Here, let me do it again. Here I've attached the carbon at the second place. Here I've attached the carbon in the third, in the middle, in the third carbon.